classes of this.
Yeah, like you see James Randi going on stage and taking an entire bottle of sleeping pills and just swallowing it, and it's fine. He's been doing it for so long. And then, there's a famous homeopathic flu remedy. I'm not going to pronounce it again. 10 is to the negative 400. That's like, at that point, you're more likely to find an atom in the entire universe than to find like a molecule. That's the order of magnitude we're talking about.
So does that mean homeopathic medicine has to be processed in like a lab?
No, it doesn't matter. As you can see, we weren't even accurate. We didn't even get to the ratio, and it doesn't make a difference. Because ultimately, you're not going to get anybody else. So this is the kind of like the paradox of the homeopathic tenet. Even if like does in fact cure like, when you dilute something this much, you get nothing. It's like it's science. It's just pure science. There's so much.
What if you have cancer? Do you inject another cancer into you to cure your cancer? How do you cut it over?
It might cure the original cancer, but then you get the second cancer.
Actually, there's a James Randi joke.
How does that work?
There's a really good James Randi joke where he talks about it. It's like, have you heard of the guy who overdosed on homeopathy in Boston? He forgot to take his meds. So,
Come on, man.
So I'll touch on the dilutions a bit more later. But the next thing is, how do they know if a drug works? Like we already know that it's fake, but how do they actually like pretend to study this thing? There's something called provings. Provings, essentially what they do is they take volunteers, so not even like a subjective trial. It's all these guys. Sorry, not even an objective trial. They take people who already believe in homeopathy, and they're like, they give them these diluted forms of the medicine, and then they record their symptoms over several months. They don't record their symptoms themselves, and as in the scientists or the people who are doing the provings don't, the patients do. So, like, not only is it like not even double blind, it's completely subjective, because different people will experience different reactions to the drug, and if they generally, there's something called placebo effect and nocebo effect, where if they think it's going to cure them or if they think it's going to make them sick, they will feel sick or feel ill, and that's a big problem. So it's completely subjective, and the only way they combat the potential to lie is they get them to sign like a contract that says like, I'm not going to lie, I'm not going to drink coffee, I'm not going to drink tea and drink wine, not alcohol, wine during this period. They haven't really found any. I mean, as you can imagine, you can't really get hard science. Like modern medicine is tested through rigorous like objective trials, double-blind trials, where they give people either a placebo or the actual drug without telling them what it is, just so they can rule out the placebo effect. But what the provings do is they just take pure subjective. It's completely subjective. And it's actually like, I mean, you get 1 or 2 cases, like a clock is always right two times with a broken clock. And it happened with like nitroglycerin, where they found out that nitroglycerin helps with heart problems. Although interestingly, even though it was proved through the homeopathic provings, they never actually used nitroglycerin in any of the homeopathic treatments. So like the one time they got it right, they didn't even use it. So maybe during Hahnemann's time these subjective trials were effective, but now we have so much more knowledge on the way the human mind works and the way the human body works and how to do statistical analysis that it's completely obsolete. Now let's go to the evidence we have right now, the evidence we have today, which is something even economists people talk about. They say there's so much evidence without actually providing such evidence. So let's look at the evidence we have so far. First of all, we've already established that there are no molecules inside. You're drinking. If you're drinking it, you're drinking water. If you're taking the pill, you're just taking like water that evaporated off sugar, which is lactose actually, to be precise. So we have no significant evidence of the molecules being there. Therefore, you can't really say. I can see the look on your face. We can't really say, like you can't really test for water, right? You can't test if water will cure cancer or something. So that's our picture. The other thing, in response to the whole, there aren't any molecules in the final product, homeopaths have come up with this idea of water memory. Have you ever heard of water memory before? Okay, this is going to be a while, right? So water memory came about from the Benveniste study, a French guy, Dr. Benveniste. I'm not even dignifying by learning his first name. So it happened in
no judgment.
In the late 80s, a French scientist, I think he was a chemist or a physician, did a study where he found out, where he did homeopathic scale dilutions like we did just now with antibodies. And he took these antibodies and he diluted them several times and to the point like what Hahnemann recommended. And he injected it into the human body. I'm not sure if he did it in vivo and vitro, but either way he exposed it to basophils, which are white blood cells you get in humans. And they found out that the antibodies created a response. Like basically the basophils responded to the presence of the antibodies. And they published it. This is big, like you win the Nobel Prize if you can do this. And they showed it to Nature, and Nature outright rejected it. Which caused quite a bit of controversy because the whole, another big thing homeopaths like to talk about is how there's a big controversy against homeopathy by big pharma, trying to oust them. When in actuality, these guys just want money. If homeopathy works, they'll be the first people to monetize it. Anyway, so Nature rejected it, and they decided to kind of test it first. They were skeptical. And they said, okay, we'll accept it if you'll do another study, the same study, under supervision. So there was a doctor called Dr. Maddox, and the one and only Dr. Maddox and someone else, who went to the Devanista's lab and watched them do the experiments. And even under supervision, they found the same results. It did cause a response from the basophils. Now, how does this doesn't make sense, does it? Like, we just saw that the molecules aren't present. If you use antibodies, they're just not going to be there. Have I been lying to you all this while? Or like maybe I have a
checking a text in the middle of your presentation.
No, look at my notes. Look at my notes, man. Sorry. Yeah. Oh, I don't know.
Yes, we have been lying to us.
So is it true? Like what? Those homeopathy, actually, no. This is the whole thing to get you guys to convert. Actually, thanks to this gentleman here, who was the other scientist who took part in the studies. This is the amazing James Randi.
Randy?
Yeah, you don't know about Randi?
No!
What? He's amazing, dude. He went to like all these sidekicks and homeopaths, and he's like, I'll give you $1 million if you can prove it works. And he like goes on TV and like debunks the shit out of these guys. It's amazing. So James Randi was the other person present with Maddox, and they decided to do a second trial with in their lab. This time they supervised it far more closely. They did it blinded, so the scientists did not know which vials contained the diluted amounts and which vials contained the original undiluted amount. And they hid it. They videotaped the lab. They photographed their notepads. Randi even he wrapped the test tubes, the labels in newspaper, put it in an envelope and hid it in the ceiling to make sure the scientists can't see it. Right? Eventually when you get the results, it will match up to the labels, but the scientists did not know when they actually wrote down the results and they wrote it down into their notepads. Can you guess what the results were?
They were conclusive.
There was no water memory demonstrated. That is completely bullshit. He even like they basically found out that it was all bullshit. Like when the scientists knew which vials had the actual working, like the undiluted form, they seemed to magically get results. But when they couldn't tell the difference between the diluted and undiluted amount, it turns out that like it's not true. But then when this French guy even accused Randi of using magic tricks to distract his scientists, just absolutely ridiculous. So that was a big one. That was a big study, and since then people have tried replicating the studies from Benveniste's lab. Even the Department of Defense did it. Nobody has been able to replicate his original results, which showed that the basophils reacted to the homeopathic antibodies. Except for a few cases. The few cases where they did find a correlation between the original findings was when the people working in Dennis's lab in the original trial were also working in the lab for the subsequent trials. Only when those scientists
Because
were
those
there.
guys had the touch.
Yeah, that's what they said. They
Correct.
said that everyone, all the other scientists magically blocked the water memory from happening. In actuality, like basic water memory says that anything you put it in will change the structure of water. Which I guess is true, but when you take it out, water's structure will change. And it only stays in a single structure for a single picosecond. A picosecond is 0.00001 second.
Sorry, what was that again?
It's an instant. It's an instant. So like water memory doesn't work. They really you don't even have to look at the first tenet, which is like kills like, because it doesn't matter. When you dilute it that much, you're just drinking water. Now we bring on to the question why I actually cared when these people. This is where I need my notes. Why I actually cared when these people were. When these people on The Economist were criticizing the anti-homeopathic movement, this is why I think it's a problem. It's a scam. It preys on desperate and ignorant people. Homeopathy is not safe. It's a strain on society. You know? What I mean by that is, first of all, you have people like Dr. Oz who spout pseudoscience, and they just take advantage of these poor people who don't know any better, who have lost faith in the system, and just spend all this money. The second thing is the vulnerable people in society suffer, and I'm reading the notes because I'm very bad at names. These are a few names, a very few names of the people who suffered. Ryan Alexander Lovett in 2013 died of a strep infection. He was a child. His parents refused to give him proper medicine. They gave him homeopathy and he died of strep infection, something that no person in a rich country should die of. Then a mother in New Zealand refused antibiotics for her baby's ear infection. She took homeopathic advice. This baby was like 2 months old or something. The baby died soon after of meningitis. And the worst thing, when the baby's condition got worse after a week of taking the homeopathy, the homeopathic doctor said, it's fine, keep taking the homeopathy, nothing will happen. And what makes it even worse than that is, the mother was a nurse in a proper hospital. She only realized that the kid had meningitis after it was too late. Then there's Cameron Ayres, died from a disease which caused an enlarged liver. It was a hereditary disease, 6 months old. Like if they had just gone to a regular doctor, the kid would still be alive. And he just died because the parents refused to give him proper traditional medicine, homeopathy. I mean, and these are children. Children can't give consent. They have no choice. They have to do what their parents say. And when you have people pushing things like homeopathy with no evidence at all, it's totally unfair. It's totally unfair on these children. The parents went to jail in all these cases, but what the hell? You still have a kid who died. A kid who had his entire life lived it. And not only is it these kids who can't consent, it's even people. Even the fact that homeopathy doesn't go through the same rigorous testing as regular medicine. Like there was a case, a court case with a company called Zcam, and they had a cold remedy, which is a nasal gel, which they said was homeopathic, and therefore it wasn't under the same scrutiny as regular medicine. 1,159 patients used it. They completely lost their sense of smell after using that drug. A simple trial, even on rats would have probably told you that it wouldn't have worked. And then there's a drain on society. The NHS, anyone who's been following British politics would know that they're making cuts on the NHS. The NHS, I think it was last year or a couple of years ago, spent £4 million. Well, on average, it spends £4 million a year just on homeopathic treatment. And the reason they do this is because Prince Charles fucking supports homeopathy.
Fuck him.
Yeah, you have these people taking advantage.
Wait, how does he have a say over a national health
He's
system?
a goddamn Prince Charles, right?
Hey, Jenny McCarthy, it was like a Playboy bunny who endorsed no vaccinations.
Yeah.
That actually makes more sense to me because she's popular.
Well, the royal family is very popular. Royal family is very popular. And this is the thing, like taxpayers have to, if you live in the UK, how pissed off would you be? That £4 million could be sent to increase the salary of these nurses who work hard and who have to go on strike and get cuts, get fired, get laid off. They spend something like £10 million on a homeopathic building somewhere in London, which is like a huge hospital. And all it was is just people giving fancy, overpriced water. And like, I don't know why this bottom part is here. Sorry.
Someone else did it. Sorry.
It's magic, okay? Somebody
I don't remember what happened there.
It's like Andy's magic.
This is what you do when you make like
But the point is like, even if you do believe it, like, it's unfair on the people who don't have a choice, don't have the opportunity to make an informed decision. And I hope I've helped you guys make an informed decision on this situation. Because I know a lot of people who do follow homeopathy have lost faith in the current medical system, not just in America, even in Sri Lanka, and I can totally understand that. Like, it's very hard to keep faith in our medical system. But the fact is, it's better than this. Like, Big Pharma isn't out to make money any more than these guys any more than like Dr. Oz or these other celebrities who make endorsements, or the companies that actually make this shit. So that's the thing. At least Big Pharma is responsible. They get sued to hell if they try to, if they like made a big mistake. And I know scientists who work in the pharmaceutical industry. Most of them care a lot about what they're doing, and most of them are under intense scrutiny. So yeah, that's like the main part of my presentation. Do you have any questions? Yeah, I've got a question. Before anything else,
Someone taste that.
Actually, before anything else,
I see you can taste the soy. Maybe it's here, but the taste is there.
Can you smell what Akash was cooking?
before I continue with the questions, another thing I saw in The Economist was people were confusing it with herbal remedies. And I wrote a response to that about it actually. If any of you actually think that herbal remedies are far better than the stuff you get in pills, I can explain why that's not true. But I didn't.
That's a different
Okay.
That was actually my first question. What's the difference between homeopathy and Ayurveda?
Like for fevers and stuff like that, like even the
Yeah.
kotamali and Vengalgata and stuff like that, they do relieve bodily aches and pains. And
Yeah,
probably
that's
not
true.
as efficaciously as
For the
Panadol and
but that's the
stuff
thing.
like that.
That's the thing. If herbal remedies didn't work, we wouldn't have normal drugs. When you're discovering a new drug, when you're trying to invent a new drug, you can't just think, okay, I'll put this molecule there, because there are thousands, hundreds of thousands of different combinations. You have to look at what nature has given us. That's the easiest way. I'll give you an example, a very basic example, but this is generally how the industry works. Everybody here has taken aspirin once in their life. And aspirin is pretty much accepted to work, and it's pretty much accepted to be fairly harmless. But what a lot of people don't know is that aspirin is actually a remedy. Around like 3000 BC was the first case where people would eat or consume the bark of a tree, either the willow tree or there were various other trees out there, thousands of them. Even the Americas there were trees that have the similar effect as aspirin, and they would eat it. And it would relieve pain, it would reduce inflammation, and help break fevers. So thousands of years later, I believe it was in the 19th century, no, the 18th century, where some chemists rediscovered this bark. I believe it is a willow tree that they used this bark. And at that time, our understanding of chemistry was far better. So they realized that they could separate out the different parts of this bark. They could separate the individual chemicals, because a bark, a small portion of the bark has thousands of different compounds. So they separated out, and they identified the chemical that was causing these therapeutic effects, which was breaking fever, reducing inflammation, and all that. They found it was salicylate, and salicylic acid. So the early users of this, rather than having to grow the tree and transport this massive bark and like have these people eat this tree that had like so many other chemicals, they were able to isolate the salicylate and salicylic acid. Actually, salicylic acid was made after that. Salicylate was what they found. They made it into salicylate, so it's more stable. And then they turned it into pill form. First they isolated it and they turned it into pill form. Then they were able to produce it themselves using the chemistry knowledge they had with salicylic acid. A couple of hundred years later, pharmaceutical companies started taking shape, and then they started playing around with this molecule. And then they realized that if they add like, I think it was a sugar, yeah, it's a type of sugar. If they added that to the molecule, they would get a far more stable compound that also had less side effects, because even though salicylate was a popular remedy, you'd still get problems like internal bleeding and like nausea and like ulcers and things like that. when they added this sugar molecule and changed the shape of and the composition of this molecule, just like a single step, they discovered something that was far less dangerous, far fewer side effects, and far more efficacious. So they could use smaller pills, thereby making it cheaper to produce and cheaper to transport. That medicine, that new compound, was called aspirin, and that's a very basic thing of how it works. Modern day, it's a bit more complicated. There are more steps involved, but the basic gist of it is they take a herbal remedy that they know to work, and then they find out what works, isolate it, and then they purify it, and they figure out how to make it on their own at industrial scale, and that's how a drug is formed. Any drug you take, chances are it comes from a natural remedy. Most of antibiotics come from, originates from bacteria you get in the ground, or fungus you get, or bacteria you get, or mold you get in bread, or like seaweed, or part of oysters. It's like paracetamol is also from a tree. A lot of cancer medicines are from trees. So it's all herbal medicines, what we're doing. It's just that we're able to isolate it, separate, purify it, and figure out, okay, how can you make it more effective? How can you make it target your brain better than your leg? How can you make it so that once you urinate it out, it's less dangerous to the environment? We can do all of that now, and that's what modern medicine does. That's why we don't eat trees and stuff. I mean, kotamani is good, but for like curing cancer and things, it is life-threatening. That's why we don't rely on like barks and shoots anymore.
But there's no proof that synthetic is better than the natural.
It is. There is proof. There is absolutely proof. There are basically, okay, so when you're developing a drug, you have something called LD50, and then you have the therapeutic dose, TD50 and all that. LD50 is basically the point where 50% of, it's like the half-life of where it'll kill people. So they test it on mice, they keep increasing the dosage until it starts killing the mice, and they reduce it by half, and that's the LD50. And the therapeutic is 50, it's the same thing, they keep increasing until you get therapeutic effect, and that's what you have. And what they do is they take these natural remedies, they separate it out, and then they mess around with the molecule, and they using our knowledge of chemistry. Like a good example is, if you want a molecule to cross the cell wall, it can't be polar. So you basically add ends to the side of it to make it less polar. But if it's too unpolar, it won't work that well in your cells, so you have to find a balance, and we know that through scientific theory. So when you find the actual molecule, you mess around, you add a few groups that make it less polar, and then you put it in rats. It's this whole process. It takes almost like, sometimes it takes decades to develop a drug like that, of rigorous testing, and using different iterations of the molecule, doing it first in rats, then in other organisms, and then when it's safe for humans, they use it on humans, and they find the most effective cause with the least side effects, and that's the drug you get in the shop. That's how it works. It's evidence-based.
But there's a problem with separation. Just like
you
separate out
okay.
like fructose out of fruit juice.
It's easy. We have, you can't do it at home, but you can do it in the lab. We have, like for instance, I work with something called an NMR. An NMR can detect something to the point of like a single molecule. When I was purifying it, trust me when I say this, I spent like more than 50% of my undergraduate thesis, which was 2 years, was purifying this thing. If there's a single thing missing, if there's a single thing extra or a single thing missing, I will find it. And there's even more accurate things that you can find out. We have multiple tests that uses technology that like people can't even imagine. Like you can't make it on your own. It will take thousands of years for someone to develop it on their own, even with the theory. And that's what we use. We can detect a single molecule. So separating it is not a problem. We can do it. It's scientific. It's like you can't argue this and say it's not true. There's no argument. It's scientifically proven. It's like trying to argue that like gravity doesn't work. It just works. That's a simple thing. Like, how long have you spent studying the pharmaceutical industry? Because I spent 4 years in university doing it.
So you're biased.
I'm not biased. If you don't understand scientists, if they find something wrong, they will jump on it. If a scientist finds, like if I publish something, I will bias towards my findings. If like some guy finds out, he's not going to be like, oh, we must protect our own. No, he'll be like, this asshole, I need to get a one up on him. If he writes a letter about it to like Nature or something, then like he'll get more credibility for debunking me. That's how it works. It's very competitive. If you make a mistake, they will find out. If anyone else finds out, they will do whatever it takes to screw you over. That's just how it works. There are so many people fighting for these jobs. It's not like a frat or anything. You're talking like some guy working in your same lab will try and screw you over. That's how competitive it is. There's no such thing as like bias or anything like that. If I find something wrong, even as an undergraduate, if I wasn't biased as you say I am biased, and I found something wrong in like aspirin or something like that, and I wrote a paper about that, I get a job. I get a high-paid job. I might even get a PhD. I might like be able to study it and write a paper about how shit this guy is and get a PhD of it. I would do that. Hell yes. That's how it works. Everybody would do it. If I don't do that, someone else will. That's just how it works. Like, you can't say people are biased. Scientists are not biased. They hate each other. Science is one of, like, the scientific field is one of the bitchiest fields out there. Trust me when I say this, like, every single scientist you meet who's written a journal will tell you it's the bitchiest field you would ever find. It's not like anything else you've ever seen.
So, what's your short answer to what's the difference between homeopathy and Ayurveda?
Well, Ayurveda is more... Ayurveda is very complicated. It's like asking what's the difference between like an orange and a grape.
Well,
it's like a big difference.
I mean, Ayurveda doesn't take the equivalent of a teacup, put it in the ocean, mix it up and take another teacup out of the ocean.
Yeah, homeopathy is...
Take the ocean, take a drop of it and add it to the ocean again.
No, it's like modern medicine, right? When you get like I said, Biloba, what they used to do in 1600s is you make Biloba tea, which is you infuse Biloba into hot water and then you let it rest for like half an hour and drink it. What we do with Kothaliputu and Venugagata and stuff is the same thing. You boil water, you put the bark of the Kothaliputu and the Venugagata and Kothumali seeds and stuff into the water, you infuse it, you wait for about half an hour, and when it's nice and black, you drink it, you strain it and drink it. So, and the thing is that basically that's the Ayurveda thing. They take tinctures, they take like extracts, essences, stuff of natural herbal stuff, which like modern medicine has gone like 16,000 steps. Oh my God, we can actually extract that a little better and make it more specific.
We're doing it now in Sri Lanka. It's picking up a lot where they take Ayurvedic medicines, they figure out what works, and they do. When I was in ITI, a lot of my co-workers were doing that.
But the thing is this, like for me, especially in the local context, given how fond our doctors are of like medicating you with every possible medicine you can think of, for certain things, I mean obviously not like cancer or like anything major like that, I prefer to take herbal medicine simply because I remember like I had a little foot infection or something, step on a nail or something, I got infected. I went to actually, and the guy landed me with like 10 days of 500 milligrams of augmentin twice a day. And luckily I had like a doctor friend who said, why are you taking this? It's a massive dose. That's like one of the, when you're in surgery, major surgery and coming out so that you don't get infected, we give 500 milligrams of augmentin. This guy's giving you that for like inflammation because you've got a nail in your foot, right? And honestly, like I took off with my grand at that time. She was like, when are you gonna get it? And I had like 5 days of when I get it. It worked, right? I'm not saying if I take an augmentin in 3 days, it would have probably got better.
But that problem with the overprescribing is that doesn't mean you should turn to homeopathy.
No,
I'm not saying you do. I'm not saying that doesn't mean you should automatically turn to alternative medicine. It just means that there is a serious problem with the way these doctors practice.
So answering the question, I think the difference is that Ayurveda doesn't dilute something 100 trillion times and then say, yeah, this is make it better.
The Ayurveda is clearly medicine. It's just
primitive medicine.
it's earlier medicine.
It's kind of like
Primitive is a Western narrative word to use there. But
I've got a question. My homeopathic doctor tells me that the Western medical establishment is an extension of the military-industrial complex.
We covered that.
I'm sorry, did we discuss that?
Yeah, we already discussed
that.
We talked about how
Not the military-industrial complex.
how George Bush wanted to go to war with homeopathy, so we already did that. We basically fired less bombs to kill more Iraqis.
So then, is that
I can't believe
vaccination
that.
basically a form of homeopathy? If you're saying like versus like, because doesn't vaccination take the...
It doesn't try to induce the symptoms. See, homeopathy specifically targets the symptoms rather than the actual disease. How vaccination works is, it